So for this lecture, we will tackle testing hypotheses for two samples. But before that, let's have some terms that we need to consider. So for two samples, we have a so-called independent and dependent samples. So we have the definition here. Two samples are independent when the sample selected from one population is not related to the sample selected from the second population. And then two samples are said to be dependent when each member of one sample corresponds to a member of the other sample. So dependent samples are also called paired samples or matched samples. For a two-sample hypothesis test with independent samples, so here are the null and alternative hypotheses. So the null hypothesis HO is a statistical hypothesis that usually states there is no difference between the parameters of two populations. The null hypothesis always contains the symbols less than or equal, or greater than or equal. For the alternative hypothesis, HA is a statistical hypothesis that is true when HO is false. The alternative hypothesis contains the symbol greater than, not equal, or less than. So let's have two-sample z-test for the difference between means. So a two-sample z-test can be used to test the difference between two population means mu sub 1 and mu sub 2 when these conditions are met. Number 1, both sigma sub 1 and sigma sub 2 are known. Number 2, the samples are random. Number 3, the samples are independent. Number 4, the populations are normally distributed or both n sub 1 greater than or equal to 30 and n sub 2 greater than or equal to 30. The test statistic is x bar sub 1 minus x bar sub 2, and the standardized test statistic is described by these two formulas. So, for example, a credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. The results of a random survey of 250 households from each state are shown at the left. The two samples are independent. Assume that sigma sub 1 is equal to $1,045 for California and sigma sub 2 equal to $1,350 for Illinois. Do the results support the group's claim? Use alpha equal to 0.05. Okay, so let us do now the analysis. So let us first find the claim in the problem. So based on the problem, the claim was there is a difference in the mean credit card debts of households in California and Illinois. So let us write it here. So there is a difference in the mean credit card debts of households in California and Illinois. Now, so where can we put this claim? It says here that there is a difference in the mean credit card debts of households in California and Illinois. So meaning, we will put this statement in the alternative hypothesis. Maybe we can copy this. And then for HO, we just do the complement of this statement. So that is, so there is no difference in the mean credit card debts of households in California and Illinois. Now, for the level of significance, so it was stated in the given, we have 0.05. For statistical test, so since the topic was z-test, so we will use z-test. And then for the p-value, we will use again megastat. So I already input the necessary information for our computation of p-value in megastat. So for this column, so this is for group 1, which is for the California group, and for this column is for the Illinois group. So I already indicate the mean, SD, and the number of samples. So let us run a z-test. So we go to megastat, hypothesis tests, compare to independent groups. So first we drag the data from this part up to this part. And then after that, we delete this. Then for group 2, we do the same procedure. So we drag from this part up to this part. And then after that, we delete this. Now, do not forget to click this summary input, and then you click for the z-test, and then we fix 95% confidence interval since our alpha was 0.05, and then you may now click OK. So here's the result. Observe that the value of the p-value has no color. That means our decision would be fail to reject HO. So take note that if the p-value is less than to the designated level of significance, so we need to reject HO. So let us now write the p-value, that is 0.4098. And then for the decision, that is fail to reject HO. Now for the conclusion, since our decision is fail to reject HO, so we are favoring HO. So meaning there is a sufficient evidence to reject the claim.